this default cube already has a subsurface modifier added to it. It is set to simple, and the levels have been bumped up a couple of times so we have enough generated topology to see this next modifier in action. Let's go to our modifier properties, and from the deform list, let's add the simple deform modifier. I've intentionally left shading set to flat, so we can get a clearer picture of the deformation across the mesh. And the default settings will show you immediately how the modifier works. There are 4 modes, and each has slightly different controls. We'll begin with twist. By default, the angle is set to 45 degrees, and the axis it is twisting the object around is set to X. The angle can be increased or decreased between 360 degrees and negative 360 degrees. You can change which axis to twist the object around, and if we add an empty object, we can use this to control where the object twists from. I'll open up the restrictions settings. I'll also edit the width of this cube along the x-axis and increase the levels of subdivision. We can apply lower and upper limits for this modifier. The first limit is measured from the lowest index face, and the second from the highest. I've made these indices viewable for clarity. The range for each spans from 0 to 1. What the limits do is set a hard limit for the modifier to stop working across a given axis. However, increasing the lower limit over the higher limit won't flip the effect. Now currently, the object is using this empty to control its point of origin. That means that the angle of deformation and the local axis are going to be affected by the position, scale, and rotation of this empty. Let's disable the origin and, in object mode, rotate this cube around the y-axis. You can now see that the twist is constrained to the cube's own local coordinates. If I rotate or move this cube in object mode, the twist remains locked to its local x-axis. I'll reassign the empty as its point of origin so that you can see that moving, rotating, or scaling this empty will affect how the modifier is applied. I'll return the limits to their defaults. And while this cube is twisted around the z-axis, let's toggle into top view so we can clearly see how locking the deform on an axis affects the results. The 2 axes available will always be the 2 that are not selected as the deform axis. You can see that the entire cross-section of the cube has been twisted. But if I lock X, everything parallel to the x-axis does not deform. Let's subdivide the mesh along its longest dimension and assign some vertices to a group. Let's make it interesting and assign 2 different areas to the same group. I'll make sure both modifiers can be seen in edit mode. And as I increase or decrease the angle, you can see how the modifier twists only those groups, but the area between the selected groups and the not selected group is what is twisted. We can also invert the effect so that the group remains unaffected and everything else is twisted. Let's return the object to its original rotation, remove any vertex groups assigned, remove any locks or limits, and switch the setting to bend. Bend has all the settings that twist does except for lock. The angle follows the local axes to bend around. If we take a look at the cube's object properties and enable axes under the viewport display, then toggle X-ray in the viewport, the X, Y, and Z arrows on this widget point in the positive directions. When we set an angle to a positive number, the object is bent in this direction, and a negative angle will bend it in the negative direction. Let's play around with some of these settings so that we can see how to achieve some interesting shapes. I'll set the angle to 180 degrees. I'll set my axis to Z, and I'll restrict the limits to 0.2 and 0.8. I'll also set the origin to the empty. Now when I move the empty along the y-axis, we can see how the position will affect it. Let's switch to taper. Now the lock restriction returns, but the angle setting is replaced by a factor. The factor corresponds to the previous angle value, but it can range from -10 to 10. Finally, we'll set the origin to empty and move the empty along the x-axis. Let's set an arbitrary factor. We'll constrain the axis to x, set some limits, and lock the y-axis. All the settings work as they did for the previous deform modes, however now the effect is a tapering. I'll reset everything to its defaults once again, and now switch to stretch mode. The settings are identical to taper, but rather than distribute the deform across the length of the object, it moves the points of deformation from the center out to the extremes of the object. Setting the origin to an empty object, you can affect the point from which the object stretches out. And if you place this at one of the extremes, or beyond, you can even achieve a smooth taper. Limits and vertex group restrictions work in much the same way. What I like most about this modifier is that even when you know what the settings do, you can get some pretty interesting results. So playing around with it is definitely something worth taking the time to do.